In this video, we are going to look at transformations of trigonometric functions using a, b, h, and v values. So if you remember, the a value is the vertical stretch or compression. The b value, which is inside the function, is a horizontal stretch or compression. The h value is a horizontal shift. When discussing sinusoidal functions, we call that a phase shift. And the v value is your vertical shift. And just like before, the B and H are in the bracket of lies, so they will trick you. So take time to recognize what they are and what the transformation is with those values. So let's look at two examples. Before we identify the A, B, H, and V values, we need to recognize that the base function is sine. So we are going to need to graph the sine function. Remember, the sine function starts at the origin. So there is the base sine function. So now we can identify our values. The a value is outside the function and it's being multiplied. So here a is equal to 3, so that's a vertical stretch of factor 3. The b value is inside the function, so here we have 2, and that's being multiplied to theta, which is our unknown variable, plus 30 degrees. So that means that b is 2, but because you're talking about the bracket of lies, it's a horizontal compression of 1/2. The h value is also in the bracket of lies, so we have theta plus 30, so that means h is negative 30, so that is a horizontal shift 30 degrees to the left. And then finally, the v value is outside the function, and here we have minus 1. So we can say that v is equal to negative 1. So how we apply these are exactly how we did with those original 5 base functions that we looked at. So you might have noticed that this h value is quite big. We're used to h values that are small, like such as the v value here, which is just negative 1. But that is because the h is a horizontal shift, and along the horizontal axis, the x-axis, this is where the angles are, and the angles are quite large. We go to 720 degrees, so our scale is bigger than it was with those original 5 base functions. So what we do need to notice is what each interval is worth. So you can see that 3 squares is worth 90 degrees. So one interval is worth 30 degrees. So we're going to just state that 30 degrees, which is our shift, is just one interval. So we just need to shift one square over to the left. And then on the y-axis, each interval is just worth 1. So now we are ready to graph the transformation. First, we apply A and B, our stretches and compressions first before we apply our shifts. So let's start at the origin. If you remember, the origin is not affected by any stretches or compressions, so that point remains the same because you are multiplying 0 by 3 and you're dividing 0 by 2. The next point here at 90 degrees, we have a height of 1. So we're going to vertically stretch it. So that height of 1 is now a height of 3. And then we are going to compress it by a half. So that x value of 90 becomes 45. Or you can see that we are 3 squares to the right of the y-axis. So half of that is 1.5 squares. So the point goes from here, stretches vertically to 3, and then compresses to 45 degrees. The next point at 180 degrees, the y value is 0, so we cannot stretch it because 0 times 3 is still 0. The x value is 180, so we're going to half that, so that's at 90. You can also count squares, which will get easier as we get to these higher degrees. So right now we're 6 squares, so now we're going to go half of that to 3 squares. And it ends up here. The next point at 270 and negative 1. So now we are below the x-axis by 1. So if you're going to stretch that vertically, we're going to be 3 below the x-axis. And then we're going to, again, horizontally compress that. Half of 270 is 135. You'd have to figure out that scale in there. So this might be easier to count squares. So it is 9 squares to the right. So we're now going to go 4.5 squares to the right. So 1, 2, 3, 4.5, and that point is going to be here. And now at 360 degrees, the height is 0. 0 times 3 is still 0. So we remain at 0, but now we're going to apply that horizontal compression of a half. So 360, half of that is 180, or you can think of squares. You are 12 squares over, so now we're going to be 6 squares over, so at 180. We're going to keep going, but we have actually just drawn one complete cycle of that new transformation curve. So we started at the origin on the midline, we went up to a maximum, back to the midline, down to a minimum, back to the midline. So that's one complete cycle. So you can see it only takes 180 degrees to complete one cycle compared to 360 degrees before the transformation. And that has to do with this B value of 2 because we're compressing it by 1/2. So to keep drawing another cycle, use your strengths. If you're good at transformations, go to the next point at 450, stretch that by 3, and then shift. So that is 15 squares over, so now it's going to be 7.5 squares over, and then draw that point. Or what you could do is use the first cycle that you've already drawn to figure out where the next points are. So from that midline, it took 1.5 intervals or squares before you reach that maximum. So from this midline, I'm going to go 1.5 squares before I reach that maximum again. And then from the maximum, it took 1.5 squares to go back to the midline. So from this point, I'm going to go 1.5 squares to go back to that midline. And then keep going. So from the midline, 1.5 squares to get to that minimum. So I'm going to do the same thing, 1.5 squares to the minimum, and then it's 1.5 squares to go back to the midline. And then we see another cycle. So this way is probably easier, just counting squares, but you really have to make sure you draw that first cycle correctly to know what the pattern is. And then you can do the same thing for the negative angle. So at the midline, on the left of that, so find another point here on the midline. On the left, I took 1.5 squares to get to that minimum. So 1.5 squares, I'm going to draw the minimum. And then after the minimum, I have to go back up to the midline. So we see that pattern of 1.5 squares. Another 1.5 squares, back up to that maximum, 1.5 squares, back to the midline, 1.5 squares, minimum, 1.5 squares back to the midline, 1.5 squares up to the maximum, 1.5 squares to the midline. So now we can apply H and V to the points that I've just drawn in pink. To do that, what I'm going to do is first think of where that midline is. So right now, the midline is the x-axis. What I'm going to do is I'm going to shift that down 1 because there's a vertical shift down 1. So I'm just going to sketch or really lightly draw that midline. You do not need to draw this midline, and if you do draw it, make sure it's very light. You don't need to do it dotted. Drawing this just might help you figure out where the points go a little nicer. It is not the same as an asymptote, so it is not required. So now let's take each point and move it one interval, 30 degrees, so one interval to the left and one interval down. So my origin, I'm going to the left 1, down 1. So if you notice, I start on the midline and now I'm ending still where I drew that new midline. And then the next point is that maximum 1 square to the left. So I'm at 1.5, so now at a half, and then down 1. So I'm going to be at half to the right and 2 up. And then the next point is on the midline, 1 interval to the left, and then down 1. So again, I'm on where I drew that new midline. And then, where was I? At the minimum, 1 interval to the left and 1 down. So now have a new minimum of -4. And then back on the midline, it was 180, 1 to the left, 1 down. So I've just drawn one complete cycle. And then you can either use that pattern to keep going, or you can use these other points and move them 30 degrees to the left and 1 unit down. If you do decide to keep the pattern going, it's still every 1.5 squares, you're hitting a midline, a maximum, or a minimum. So right now I'm on the midline, so 1.5 squares later, I'm going to be at that maximum, but that new maximum is 2. 1.5 squares later, I'm back to that midline. 1.5 squares later, I'm back to that minimum. 1.5 squares later, I'm back to that midline. So it's still every 1.5 squares because we've already applied A and B, which would affect how often we have a key point. So there, the purple function is the final transformation function. So I've labeled that here. The pink one is just with the A and B applied. So now the domain, so we can see the domain is still theta is an element of all real numbers. And then the range is restricted in between the minimum, which is now -4, and the maximum, which is now 2. So we start at the smallest number, y is less than or equal to y, which is less than or equal to the greatest number. In question 2, we see that the base sinusoidal function is a cosine function, so we're going to draw that on the curve. Remember, a cosine function starts at the maximum. So we're going to start up here at 0, 1. So there's a cosine function. Let's identify ABHV. A is -1. So that means there is a reflection in the x-axis. The B value is 1/2. So that means there is a horizontal stretch of 2. The H value is 45, positive 45. And V is -3. So a vertical shift 3 units down. So again, just before we graph, we should just figure out what 45 degrees is in terms of intervals. So one interval is 30 degrees, two intervals 60 degrees. So 45 degrees is 1.5 intervals. So let's graph A and B. So we are reflecting the x-axis and a stretch horizontally by factor 2. So this first point, which is a maximum, at 0, 1, we are going to reflect that in the x-axis. So down here at 0, -1, and we can't horizontally stretch that because we have an x value of 0. 0 times 2 is still 0. This next point at 90, 0 is on the x-axis, so we can't reflect it in the x-axis. It stays the same place. Also, if you think the y value is 0, 0 times -1 is still 0. And then a horizontal stretch of 2. So right now we're 90 degrees to the right, so we're going to stretch it to 180 degrees to the right. So we multiply it by 2. Also, you can think of squares. 3 squares to the right becomes 6 squares to the right. The next point, this minimum value at 180, comma -1. If we reflect that in the x-axis, we're now above the x-axis at +1. And then when we stretch that, 180 times 2 is 360. So 6 squares becomes 12 squares. So we end up over here. And then the next point here at 270 is on the x-axis. So again, the reflection won't affect it. And then if we stretch it, right now we're 9 squares. So we're going to double that. So 270 times 2 is 540. So it's going to be here at 540 on the x-axis. And then the point at 360 at a maximum of 1, reflect that in the x-axis to get to -1, and then you're going to stretch that. So 12 intervals becomes 24 intervals, or 360 times 2 is 720. So that's going to be over here. So now if we connect that, that is one cycle. It's a long cycle, but that is one complete cycle. So let's look at the pattern that's happening with this one complete cycle to finish this graph when the angles are negative. So if you notice, from the minimum to the midline, it took 6 squares. From the midline to the maximum, 6 squares. Maximum back to the midline, 6 squares. Midline to the minimum, 6 squares. So going to the left, 6 squares to the left, we are then going to be on that midline. 6 squares to the left, we then have to be at a maximum. So we can just finish that curve. So now we just need to shift those points 45 degrees to the right and 3 units down. So because we're shifting 3 units down, I'm just going to lightly draw where that midline is, which is 3 units down. Again, you don't need to draw this. That's just for reference. And now I'm going to take those pink points and I'm going to apply those transformations. So first here at 0, -1, 45 degrees to the right is 1.5 intervals, and then 3 down, 1, 2, 3. So again, I remain a minimum. Next, here at 180 and 0, 45 degrees to the right, 1.5 squares, and then down 1, 2, 3. So you see I end up back on that midline. And then the next at 360, 1.5 squares to the right, 1, 2, 3. So it remains a maximum. And then you keep going. What you will notice is that this point at the end at 720 -1, because it's on the right, when you shift to the right, you're going to be off the grid. You don't have to include that, but that would be a minimum, so it would look somewhere about there. And then make sure you finish where the angles are negative. So again, 1.5 squares to the right and three squares down. And then you can connect those points to make your curve. So make sure you label your curve. And then the domain and range, well, the domain again is theta is an element of all real numbers because there's no restrictions, and the range is between the minimum, which is -4, and the maximum, which is -2.